As per our introduction in ADM TOGAF on how to develop a architecture for enterprise, in this session I will talk about the information systems architecture. The objective of this phase C, is to develop the target information systems consisting of data and application architecture, describing how the enterprise information systems architecture will enable the business architecture and the architecture vision. In summary, the information systems architecture describes the information systems architecture for a project, including the development of data and applications for this architecture. First, the objective is to develop the target information systems architecture, describing how the enterprise information systems architecture will enable the business architecture and the architecture vision in a way that addresses the request for architectural work and stakeholder concerns. The second point is to identify candidate architecture roadmap components based on gaps between the baseline or in other words current information systems and the target information systems, including the data and the application architectures. In order to do that, we have an approach, and in this approach, in phase C, the approach involves some combination of data and application architecture in both order. Advocates exist for both sequences. For example, in enterprise architecture planning recommends that data-driven approaches. On the other hand, major application systems such as those for enterprise resource planning, EPR, and so on, the customer relationship management and often provide combinations of technology infrastructure and business application logic, and some organizations take an application-driven approach whereby they recognize certain key applications as forming the core underpinning of the mission-critical business processes and take on the implementation and integration of those core applications as the primary focus of our architecture efforts. If you want to look at what are the inputs of this phase, very similar to the in terms of number of inputs to this phase are the reference material external to the enterprise. As we described before, this is enterprise architecture bucket full of all the pre-existing architectural reference models that we can use. Another one is the non-architectural input, things such as a request for architectural work. This is a document that is sent from responding organizations to the architectural organization to trigger the start of an architecture. The other thing is the capability assessment. Before starting or jumping into the detailed architectural definition, it is valuable to understand that the baseline and the target capability level of the enterprise. This is a capability assessment that can be examined on service levels. The other input that we can discuss is the communication plan. Enterprise architecture contains large volumes of complex and interdependent information. Effective communication or effective communication of targeted information to the right stakeholders at the right time is the critical success factor for enterprise architecture. So developing or the development of a communication plan for architecture allows for this communication to be carried out within the planned and managed process. So that's why it's really important. The other type of the input is the architectural inputs. Architectural inputs such as organizational model for enterprise architecture. Within that, we can have things such as scope of organizational impact, maturity assessment, gaps and resolution approach or solution approach, roles and responsibilities for architectural teams, constraints and limitations of architectural work, budget requirements, government and support strategies or governance strategies. The other thing is the tailored architecture framework. We need to have a look at things such as tailored architectural methods, tailored architectural contexts such as deliverables and artifacts. We're also looking at the application principles, of course, if exists. We need to look at things such as data principles and statement of architectural work, architectural vision, architectural repositories, or things such as reusable building blocks, organizational specific reference models, and organizational standards. We also need things such as draft architectural definition documents, which probably include things such as baseline business architecture, target business architecture, baseline data architecture, target data architecture, baseline application architecture, and target data application architecture. This phase is, as we know, information systems architecture is a combination of data architecture and application architecture, and they are pretty much interrelated. We're also looking at the draft architecture requirements, which will introduce things such as gap analysis results from business architectures or from business architecture, relevant technical requirements that will apply to this phase. And finally, we're looking at business architecture components of the architectural roadmap. And these are the inputs. Of course, the inputs are not rock solid inputs, and it's not concrete inputs. And some organizations, these are suggested ones, of course, and some organizations may pick and choose between the things. But majority of these documentations are really necessary in order to make a precise and proper architectural design within the steps that we're going to introduce. Okay, so in this phase we have two different major steps. One is to define data architecture, and the next is to define information architecture. Okay, let's start with data architecture. Okay, what is the objective of data architecture? develop the target data architecture that enables the business architecture and the architecture vision while addressing the request for architectural work and stakeholder concerns. Next, identify candidate architectural roadmaps, a component based upon gap between the baseline data architecture and target data architecture. In order to achieve that, we have an approach. In this approach, we use a particular methods. Firstly, key consideration on the data architecture. So what is the important considerations that we need to take into account? Data management. When an enterprise has chosen to undertake a large-scale architectural transformation, it is important to understand and address data management issues. A structured and comprehensive approach to data management enables the effective use of data to capitalize on its competitive advantage. Okay? In order to do that, we need to have a look at things such as a clear definition of which application components in the landscape will serve as the system or record or reference or enterprise master data. We need to answer questions such as, will there be a enterprise-wide standards that all application components, including software packages, need to adopt? We also have to clearly understand how data entities are utilized by business functions, processes, and services. We need to have a clearly understanding how and where enterprise data entities are created, stored, transformed, and reported. We need to know what will be the requirements for software in support of data integration with the enterprise customers and suppliers. Okay? And next thing we need to have a look is data migration. Okay? So what do we do in order to do the data migration? When an existing application is replaced, there will be a critical need to migrate the data to the new application. The data architecture should identify data migration requirements and also provide indicators as to the level of transformation, weeding, and cleansing that will be required for the present data in the format that meets the requirements of the new target application. The objective being that the target application has quality data when it is populated. So that's why in order to give quality data to our new target application, we need to have the cleansing requirements for the migration and a plan for that. Okay, so the other thing we need to look at is data governance. Okay, in order to do the data governance, we need to consider ensuring that the enterprise has the necessary dimensions in place to enable the transformation. Okay, so in order to do that, we need a structure. This dimension pertains to whether the enterprise has the necessary organizational structure and the standard bodies to manage data entities aspect of the transformation. Next thing is the management system. For that, so here the enterprise should have the necessary management system and data related programs to manage the governance aspect of the data entities. Also, people this is really important. If the enterprise lacks such a resource and skills, the enterprise should consider either acquiring those critical skills or training existing internal resources to meet the requirements through a well-defined learning program. Right? Next important major thing in approach is the architectural repository. As we discussed in a few sessions ago about how the TOGAF works, we mentioned that the architectural repository is the most important part that provides us with pre-existing external reference models for enterprise architecture as a whole. Within that, we mentioned things such as ARTS that has defined a data model for the retail industry, for example, or this is another example such as Energistics that has defined a data model for the petrotechnical industry. These two are just examples of architectural architectural definitions and architectural reference models that we can use depending on which industry we are going to develop in. All right, after this, we need to know what steps we need to take in order to do our data architectural properly. We need to select the reference models and viewpoints and tools. To do that, we need to, determine well-defined processes. For each viewpoint, select a model needed to support the specific view required. Use the selected tool or method. Then ensure that all stakeholder concerns are covered. If they are not, create a new model to address the concerns not covered, or augment existing models. Another is to identify required catalogs for data building blocks. Organization's data inventory is captured as a catalog within the architectural repository. That's how usually happens. Catalogs are hierarchical in nature and capture a decomposition of the meta-model entities and also decomposition across related model entities. For example, logical data components, physical data components, and data entities, and so on. Catalogs from the raw material for for development of matrix and diagrams, and also act as a key resource for portfolio management or portfolio managing the business and IT capabilities. Once the data requirements are consolidated in a single location, it is possible to refine the data inventory to achieve the semantic consistency and to remove gaps and overlaps. Next, we need to identify required metrics. Metrics show the core relationships between related model entities. Metrics form the raw material for development of diagrams and also act as a key resource for impact assessment. At this stage, an entity to application matrix could be produced to validate these mappings. Next thing, looking at identifying the requirement diagrams. Okay, what kind of diagrams we need to we will require in order to do or map our data architecture. Diagrams present the data architecture information from a set of different perspectives or viewpoints according to the requirements of the stakeholders. Once the data entities have been defined or refined, a diagram of the relationships between entities and their attributes can be produced. It is important to note that at this stage that information may be a mixture of enterprise level data and local level data held in personal databases and spreadsheets. The level of details or level of detail modeled need to be carefully assessed, and it's really important. Some data diagrams I could probably mention is like things such as conceptual data diagrams, logical data diagrams, data dissemination diagram, data lifecycle diagrams, security diagrams, migration diagrams, and so on. The next thing we need to consider, or the next step we need to consider, well, minor step within the first big step, is the identifying types of requirement to be collected. Okay, so what kind of requirement we need to collect? Once the data architecture catalogs, matrix, and diagrams been developed, architecture modeling is completed by formalizing the data focused requirements for implementing the target architecture. There are three major requirements that we could probably mention. One is relate to the data domain. The other provides the requirement input into the application and technology architecture, and the other one is what provide detailed guidance to the reflected during design and implementation to ensure that the solution addresses the original architectural requirements. Within this step, the architect should identify requirements that should be met by the architecture. And next major step that we need to consider is to develop a baseline data architecture description. Okay, so this is the current situation of our data architecture, or in some cases we call it as is situation. Here we develop baseline descriptions of the existing data architecture to the extent necessary to support the target data architecture. The scope and the level of details to be defined will depend on the extent to which existing data elements are likely to be carried over into the target data architecture. Okay. Next major step in here is to develop a target data architecture, which in some cases we call to be situation or to be state of this enterprise architecture. For that, we need to develop a target description for the data architecture to the extent necessary to support the architecture vision and the target business architecture. The scope and the level of details to be defined will depend on the relevance of the data elements to attain the target architecture, and on whether architectural description actually exists. Okay. next thing we need to consider is the performing the gap analysis. So now we know in step 2 we know the baseline data architecture or our as-is situation. In step 3 we define our target data architecture, and now in step 4 we need to figure out the gap between the two. Okay, so for that we verify the architecture models for internal consistency and accuracy. To do that we perform trade-off analysis to resolve conflicts among the different views. We validate that the model supports the principles, objectives, and constraints. We note changes to the viewpoint represented in the selected models from the architecture repository and documents. And finally, we test the architecture model for completeness against the requirements. Right? After this step, we were looking at defining the candidate roadmap components. Okay, now we need so we figured out what is the gap. Now we are looking for a roadmap to achieve the target by filling up this gap between as is and will be or to be. Once the data architecture is finalized, it is necessary to understand any wider impact or implications. At this stage, other architectural artifacts in architectural landscape should be examined to identify things such as does the data architecture create an impact on any pre-existing architecture? Have recent changes been made impact the data architecture? Are there any opportunities to leverage work from this data architecture in other areas of the organization? Does this data architecture impact other projects? Will this data architecture be impacted by other projects? These sets of concept or mini steps in this is pretty much standard across all the types of ADM architecture in TOGAF. We mentioned the same thing in business architecture as well, and it will be the same in technology architecture as well. Right. Next step, step 7, is to conduct formal stakeholder reviews. We need to check the original motivation for the architectural project and statements of architectural work against the proposed data architecture. We need to conduct an impact analysis to identify any areas where the business and application architecture may need to change to cater for changes in data architecture. For example, changes to form a procedure or application or data systems and things such as that. And then next step is step 8. We need to finalize the data architecture. To do that, we select the standard for each of the building blocks, reusing as much as possible from the reference models selected from the architectural repository. We fully document each building blocks. We conduct final cross-check of overall architecture against business requirements. We document final requirements traceability report. We document final maps of architecture within the architectural repository. We also finalize all the work products such as gap analysis and so on, right? And final step in data architecture is to create the architectural definition document. Document rationale is for the building blocks decisions in the architectural definition document. We prepare data architectural sections of data architectural definition document such as business data model, logical data model, data management process model, data entity or business function matrix, data interoperability requirements such as XML, schema, security policies, and so on. If appropriate, using the reports and or graphical generation by modeling tools to demonstrate the key values or key views of the architecture. And that's it for now. Now next thing we need to look at is our application architecture and to see how this relates to our. To do so, we're looking at the objectives. Okay, so the first objective of application architecture is to develop the target application architecture that enables the business architecture and the architectural vision while addressing the requests for architectural work and stakeholder concerns. The next one is to identify candidate architecture roadmap components based upon the gap between the baseline and target application architecture. To do that, our approach is to consider the architectural repository. In architectural repository, we're looking at the generic business models relevant to the organization's industry, vertical industry sector. For example, things such as telemanagement form, OMG, and things like that. We're also looking at application models relevant to common high-level business functions such as electrical, commerce, supply chain management, etc. So these are just an examples of some architectural reference models that are available for different types of industries that we could be using in order to apply it to a specific organization or a specific enterprise architecture. Right? In order to achieve application architecture, we need to undertake certain steps. We're looking at selecting the reference models, viewpoint, and tools, just everything else. To do that, we review and validate the set of application principles. Or if you don't have it, you look at generating those application principles. We select the relevant application architecture resources, things such as reference models, patterns, and so on, from architectural repository on the basis of business drivers and stakeholders and their concerns. We select relevant application architecture viewpoints, for example, stakeholders of the application, viewpoints relevant to the functional and individual uses of applications, and etc. Okay. We need to determine overall modeling processes. To do that, for each viewpoint, we select the model needed to support the specific view required for that view, for that model, using whatever tools that we selected. We need to ensure that all stakeholder concerns are covered by selecting appropriate model for that stakeholder, for that particular view. We need to understand the list of applications or application components that are required based on the baseline application portfolio. Next, we need to identify required catalogs of application building blocks. The organization's application portfolio is captured as a catalog within the architectural repository. Catalogs are hierarchies in nature and capture a decomposition of meta-model entities and also decomposition across related model entities. Two most important catalogs that I could probably mention is application portfolio catalog and interface catalog. All right. Next thing or next step is to identify required matrices. Okay. Matrix show the core relationship between related model entities. Matrix from the raw material for the development of diagrams and also act as a key resource for impact assessment. To do that, we need to look at things like application organization matrix, role application matrix, application interaction matrix, and application function matrix. Next step, or next mini step within our selecting reference model step, is to identify required diagrams. As we know, as we mentioned before, diagram represents the application architecture information from a set of different representatives or perspectives or viewpoints according to the requirements of that particular stakeholder. Once the desired functionality of an application is known, it is necessary to perform an internal assessment of how the application should be best structured to meet this particular requirements. Some diagrams could be suggested, such as application communication diagrams, user location diagrams, enterprise manageability diagram, software distribution diagram, use case diagram, and so on. And next mini step is to identify types of requirement to be collected. Okay, to do that, we look at relationship or related to application domain, and within that we recognize the requirements that we need to collect. Once the application architecture catalogs and matrices and diagrams developed, architecture modeling is completed by formalizing the application focused requirement for implementation or implementing the target architecture. Next major step is developing baseline applications architecture. To do that, we develop a baseline description of the existing application architecture to the context necessary to support the target application architecture, right? This is again we mentioned in other in dot architecture steps, is the same to dot architecture steps. Sorry, there's a typo here. This should read application. So say this application. That's as much as I could read. Right, so Next step is to do a developing the target architecture description. Again, this is supposed to be data, not this is supposed to be application, not data. We develop a target description for application architecture to the extent necessary for this architectural vision. Next, we create a gap analysis between architecture. To do that, we perform trade-off analysis to resolve the conflict among the different views. We validate models, support the principles, objectives, and constraints. And similar to data architecture, we do test architecture models for completeness and against the requirements. Step 5 is to define the candidate roadmap. We wanted to know what exactly we need to do in order to fill the gap between the current architecture and target architecture. And finally, next step is to resolve the impact across the architectural landscape. Once the application architecture is finalized, at this stage, other architecture artifacts in architectural landscape should be examined to identify things such as, does the application architecture create an impact on any pre-existing architecture? Have recent changes to architecture made impact application architecture? Also, we need to know, are there any opportunities to leverage work from this application architecture to other areas of the organization? Does this application architecture impact other projects? Will this application architecture be impacted by other projects, and so on? We need to conduct formal stakeholders reviews. To do that, we check the organizational motivation for the architectural project and the statements of architectural work against the proposed application architecture. We conduct an impact analysis to identify any areas where the business and application architecture may need to change to cater for changes in this new application architecture. For example, changes to forms and procedures, database systems, and so on. Finally, we select standards for each of the building blocks, reusing as much as possible from the reference model selected from the architectural repository. Fully document each building block. We conduct final cross-check for overall architecture against business requirements, and we document final requirement traceability report. We document final mapping of architecture within the architectural repository, and we finalize all the work products such as gap analysis and so on. And finally, the last step is to create the architectural definition document. To do that, we document rationale for building block decisions in the architectural definition document. Also, we prepare an application architectural section for the architectural definition document, if appropriate, of course. Use reports and or graphic generation by modeling tools to demonstrate key views of the architectural and routine document for review by relevant stakeholders and incorporate all the feedbacks. Okay, this